Today we are going to solve some of the questions from quantum chemistry, and who are facing problem for quantum chemistry. There are some simple questions which we can answer. I also not that good in quantum chemistry, so we'll solve those questions. The first question is the energy difference in a sorry the difference in energy level n equals to 2 and n equals to 1 of a particle in the one-dimensional box is 6 unit of energy in the same unit. So what is the energy difference between the energy difference in levels of n equals to 3 and n equals to 4, n equals to 2 for above system? So we know that in one-dimensional box energy En is given by n square h square by 8 square. Okay, so when we have two energy states, that time En will be h square by 8 square n2 square minus n1 square. Okay, so the energy difference between n equals to 2 n equals to 1 is 6 unit. First we have to calculate how much energy for this unit, then we will go for this. So now h square by 8 square, so this will be 2 square minus 1 square, this total equals to 6 because the energy difference is 6. So this comes out to be like 4 minus 1 3 h square by 8 square, this is 6. So 3 ones 3 twos, so finally h square 8 square equals to 2. So now we'll go for the n equals to 3 to n equals to 2 and n equals to 3. So now En equals to h square by 8 square 3 square minus 2 square. So we know that h square by 8 square equals to 2, so that 2 will substitute here. 2 into this will be 9 minus 4, 2 5s are 10. So this is the answer. So this is very simple. We have to calculate by this way. I hope it's clear. And the second problem here we have the particle in one-dimensional box of length L has an energy of 14 h square by 8 square. The degeneracy of the state. So degeneracy means we know that how many possibilities, we can say degeneracy means how many possibilities. So just for 14 we have to write the degeneracy. So like n1 square plus n2 square plus n3 square, this is has to equals to 14. So let's take 2 square plus 2 square plus 1 square, how much it will be? 4 4 1, this will be 9, so not this one. 2 square plus 2 square plus 2 square, this will 4 4 4, this will be 12, not this also. 2 square plus 3 square plus 2 square, this will be 4 4 8 plus 6 14. So this is the correct answer. So 2 square 3 square 2 square is equals to 4. So now 4 plus 6 plus 4. Now we have to calculate the degeneracy of this one. So like here for 14, n1 square has to 2, n2 square equals to 3, and 3 square equals to 2. So whatever the number is common here, that we will not be taking. So here 2 is common, so that we will be taking only one time. So 3 plus 2 equals to 5. So this is the degeneracy of this one. If it is like 9 h square by 8 square, then it will be, this is the answer. So 2 plus 1, degeneracy is 3. If it is 12 h square by 8 square, then degeneracy will be 2, like that. And the next question here we have the degeneracy of excited state of a particle in three-dimensional cubic box with energy 3 times its ground state energy. Okay, so what they have said that excited state energy is 3 times of ground state energy. This point is very important. So if you can calculate the ground state energy, then you can just multiply the ground state energy by 3, so you will get excited state energy, and after that you can see the what is the degeneracy of that energy state. Okay, so this is in a three-dimensional box. E n equals to n square h square by 8ma square n1 square plus n2 square plus n3 square. So just remember, in three-dimensional box, like ground state means n1 equals to n2 equals to n3 equals to 1, and first excited state means n1 n2 equals to 1, and one term will be 2. We can also write like this: 1 1 1, this is for ground state, 1 1 2, this is for first excited state, and if second excited state, then 1 2 2, and if it's third excited state, that will be 2 2 2, like this. So these energy states you have to remember if you want to solve this kind of problem. So first excited state means ground state means 1 1 1, so this will be h square by 8ma square, 1 square plus 1 square plus 1 square, this will be 3h square by 8ma square. So this is the ground state energy. So in the question they have mentioned that excited state energy is 3 times of ground state energy. Just multiply this one by 3, you will get a 9h square by 8ma square. So this is the energy of the excited state. Now we have to calculate the degeneracy for 9. So 9 degeneracy, before I said 2 square plus 2 square plus 1 square. This is 4 plus 4 plus 1. This is equals to 9. So whatever the numbers are repeated, those numbers we will not be taking. So this one number we will not be taking. Means repeating means we will take it as only 1. So this will be 2 plus 1 3. So the degeneracy, the answer here is equals to 3. So first you have to identify the ground state energy, and he said the 3 times, so just multiply this one by 3, so you will get excited state energy, and after that you will be calculating the degeneracy. Okay, here answer is 3. This is answer. Next, the degeneracy of excited state of a particle in a three-dimensional cubic box with energy 2 times its ground state energy. So we have calculated the ground state energy, that is 3h square by 8ma square for three-dimensional box. Now we said that 2 times, that just multiply by 2, this will be excited state energy. Okay, so here is said 6, that means degeneracy will be 1 square plus 2 square, this will be 1 plus 1 plus 4 6. So here we have to take only 2 terms, 2 plus 1 equals to 3. The degeneracy of this excited state equals to 3. So answer is this one. Next, compare the energy difference between the first excited state, ground state of 1D, 2D, 3D box. So for this is for first 1D box, n square h square by 8ma square. This is for two-dimensional box, if they ask energy difference, then negative will come. If they ask energy, then we have to take positive only. And for three-dimensional box, n1 square n2 square plus n3 square. So here is asked for a first excited state and ground state. First 1D box. For 1D box, ground state will be 1. So yeah, 1 will least energy, that is ground state. And first excited state will be 2. Second excited state 3. Third excited state 4, like this. And when we have 2D box, first excited state here N1 and N2 will be 1 and 1. And in the ground state, first excited state will be 1 and 2. One energy will be 1, another will be 2. And if they ask second excited state, then it will be 2 and 2, like this. And for 3D box, for ground state, all terms will be 1 1 1, nx ny nz. And if it's first excited state, then 1 1 2. Second excited state 1 2 2. Third excited state 2 2 2, like this. Okay, so first now we have to identify the energy difference of these terms. Okay, now so for first we will take for 1D box. So here 1D and ground state will be, ground state energy is equal to 1. That means En 1 square h square by 8 ma square, this equals to h square by 8 ma square. And now excited state. So what is excited state here? 2. That will be 2 square h square by 8 ma square, this equals to 4 h square by 8 ma square. And the difference, if you see the difference comes out to be 3 h square by 8 ma square. This is the difference between the ground state and excited state in 1D box. Now we'll go for the 2D box. In the ground state we have a 2 energy state, 1 and 1. So En will be h square 8 ma square 1 square plus 1 square. So this comes out to be 2h square by 8 ma square. For 2-dimensional box and 3-dimensional box, h square by 8 ma square will be is equals to r. So this we will write it as 2r. And for excited state, here we have 1 and 2. h square by 8 ma square 1 square plus 2 square. This comes out to be 4 plus 1 5h square by 8 ma square. And the difference between the ground state and excited state will be 5 minus 2 3 3h square by 8 ma square. Now we'll go for the 3D box. So for ground state we have 1 1 1. So En equals to h square by 8 ma square 1 square plus 1 square plus 1 square. This comes out to be 3h square by 8 ma square, and this is 3r, and this will be 3r. And for excited state, here we have 1 1 2 h square by 8 ma square 1 square plus 1 square plus 2 square. This will be 4 5 6 6h square by 3 ma square. And if you see the difference, here also 3r. And if you see the energy of first excited state and ground state and first excited state of 1D 2D 3D is equals to same. Here 3h square by 8 ma square, here also same, here also same. So energy of, if imagine that this difference, if the difference between the ground state and excited state, if it is a E1 and in 2D is E2, and if it is in 3D is, if you take it E3, then E1 equals to E2 equals to E3. Okay, I hope it's clear, it's not that difficult. If you can remember these energy states, then just substitute them in this h square by 8 ma square, so you will get the answer. And next we have for the first excited state and second excited state of 1D, 2D, 3D. And here we have already calculated for now they ask for first excited state and second excited state and second excited state. So for 1D, first excited state energy is this one, 4h square by 8ms square. For 2D, first excited state energy is this one, 5h square by 8ms square. For 3D, first excited is this one, 6h square 8ms square. Now we'll calculate for the second excited state. So you have to remember these values so that it will be very easy. So for 1D, second excited state is 3. So 3 square h square by 8ms square, this comes out to be 9h square by 8ms square. And the energy difference with this one will be now 5h square by 8ms square. Now for 2D box, we have second excited state 2 and 2, h square 8ms square, 2 square plus 2 square. So this will be 4 plus 4, 8h square by 8ms square. And if you see the energy difference between this and this will be 3h square by 8ms square. Now for 3D box and second excited state means this one, h square 8ms square, 1 square plus 2 square plus 2 square. This comes out to be 4, 4, 8 and 9 h square by 8ms square. And this will be, if you see the difference between this and this comes out 3h square by 8ms square. If you take the energy difference between the first excited state and second excited state of 1D as E1 and 2D as a E2 and 3D as a E3, now which is more energy? First 1D box is more energy, so E1 is greater than E2 is equals to E3. So this is the relationship. So this question asked I think last year in CSR exam. So you can just remember these energy states, so it's very easy to calculate. And then we have this question, sp hybrid orbitals are of form C1 2s C2 2pz, the value of coefficient r. So this is also one of the simple question. Just remember that anything, if we have you have integrals, the square of them is equals to 1. It has to be equals to 1. So first we will take this one. That means like C1 1 by 2 square plus, and this also 1 by 2 square. So this will comes out to be like this is 0.5 0.25 plus 0.25, it comes up to 0.5. So this is wrong, because if you're doing squares, that has to be equals to 1, then only the answer is correct. I don't know what is the reason also, just like that I am explaining, because I am not that good in quantum chemistry. And here 1 by root 2 square plus 1 by 2 square for third option I am doing. So this get cancelled, and this comes out to be 0.5 plus 0.25, this comes out to 0.75. This is also not correct answer. And I will take this one, 1 by root 2 square plus 1 by root 2 square, root get cancelled, this will 0.5 plus 0.5, this equals to 1. So this is the correct answer. So if you find this kind of questions, just square them. After square it has to be equals to 1. So that is correct answer. and here we have psi is equals to 0.8 psi a plus 0.4 psi b in a normalized molecular orbital of diatomic molecule AB. The overlap integral is, so here one principle is there, that is c1 square plus c2 square plus 2c1 c2, this equals to 1. Okay, so here c1 means 0.8, c2 means 0.4, 0.8 square plus 0.4 square plus 2 into 0.8 into 0.4 s is equals to 1. So this will be 0.64 plus 0.16 plus 0.32 0.64 is equals to 1. So finally if you calculate s value, this comes out to be 0.2 by 0.64, it comes out to be 0.3. Just remember this principle, c1 square plus c2 square, this is just like a square plus b square plus 2ab is equals to 1. So just remember this principle. If they ask this kind of question, you can answer. I think in the last year gate question, they have last year in the gate exam they have asked this kind of question. I did not collect that question. I forgot. I will collect it in a next video. I will make few more questions, so there I will cover that question. And next question we have, a particle is constrained in one-dimensional box of length 2a with a potential of this one. The energy difference between the n equals to 2 n equals to 3 is so here we have a energy h square n square by 8 ma square. So a value is 2a here, that will substitute here. Now energy we have 2 and 3, and h square 8 ma square. So here energy, he said energy difference, that means we have to use the negative, n1 square minus n2 square. So here h square by 8 m, this will be 2a square. What are the energy differences, like 3 and 2, 3 square minus 2 square, h square by 8m into 4a square, this comes out to be 9 minus 4, so 5h square by 32 ma square. This is the answer. Okay, just so this is the way to calculate answer for this question. And here we have one last question, that when nitrogen atom is placed in a electrical field along the y-axis, the orbital that mixes most with the ground state 1s orbital is. Here also I am not going to explain what is the here answer is 2py. Here also I am not going to explain what is the answer, because it's like just remember that if they placed along y-axis, 2p y orbital mixes most with 1s orbital. If they placed along x-axis, 2p x orbital mixes most with 1s orbital. If they place along z-axis, then 2p z orbital mixes with 1s orbital. I am thinking like this is x, z, y axis, right? So if they are placing some what they placed, if they are placing along y-axis, this y-axis and 2pz, so 2py axis, 2py orbital, they have same symmetry, right? this y orbital and 2py orbital, they have same symmetry, so there will be maximum overlap we can see here because of the same symmetry. I'm thinking this could be the reason. Okay, so just remember, if they if they ask question that they have placed hydrogen atom along y-axis, the 2py orbital will be having a more overlap with 1s orbital. If it is along x-axis, 2px will be having more. If it is z-axis, then 2pz orbital will be having more. And this is the reason that because of y orbital, they placed along y-axis 2py orbital and y-axis, they have same symmetry. Because of that, you will get the maximum overlap. So this is these are the some questions I have collected, and I will make one more video, like I will collect a few more questions, then I will make one more video on quantum chemistry. Means I am not going to collect difficult questions. I am going to do only simple question, because I am not that good in a quantum chemistry. In case if these questions are repeated in the exam, then you will be getting benefited.